exponential laws and definitions. So obviously we have gone through some basics, but we are definitely going to get into some more complicated problems. But trust me when I say you might not find them complicated, especially if you understood all that you did in the introductory lesson. So do not worry that much. Don't be intimidated by the word complicated. Everything that I'm going to teach you, it is definitely going to make sense. You just need to make sure that you pay maximum attention and do not write as I'm explaining. Just watch and listen. You will have an opportunity to watch this same lesson again in case if for the second time you'll be watching it for the purpose of writing down the notes. So let's say we are raising a fraction to a power, and let's see how we work it out. Not that much complicated. So this is an additional law of exponent where we can say we have a base, let's name it A, then we have another base, let's name it B, and then let's say this is to the exponent of n. So always when we are dealing with the laws of exponents, please be aware that you need to always remember that even though it may not be written, but there is an invisible one there for each base. How do you know that you are now dealing with the laws of exponents, or you need to apply the laws of exponents? This is how I've noticed at an early age to say the moment you have a number as a base and then you have a letter as an exponent, that's when you know you are going to need to apply the laws of exponents. So that means number as your base and then exponent being the letter. That's how you know you will need to apply those laws of exponents. But if it's vice versa, then you won't need to. It's in most cases where you may not need to. Okay, then it's fine. So this one, obviously we know that if we did not have this part, it was just going to be a to the exponent of n, because it's 1 times n. So the same applies here. It's just that you do it 2 times. So that means it will be that a 1 times n, it is n. You still do it for that one because it's a fraction where you say b 1 times n is n. That's how it works. That's how easy it is. So this multiplies the exponent for each base. So that means it will multiply exponent for the numerator and exponent for the denominator. That's how you easily work it out. Maybe let's just do a few examples and see how we apply that law. Let's say we have example A, where we have, let's say, A over B to the exponent of 5. The answer for this one, it should just be A to the exponent of 5 over B to the exponent of 5, simply because you have invisible 1. That's it with that one. Now let's do this interesting one, because I want to train you on some problems which involves the negatives and all of that, so that you can see how you deal with the negatives when you are applying the laws of exponents. So this one, be very careful always when you are dealing with a negative base, and that base being a number. Put it inside the brackets and say -3 to the exponent of that, and then this one you can just easily multiply it and say 3 times 2. And then be very careful. Remember, squared means 2 of exactly the same thing. So it's like you are having -3 that you are multiplying again with -3. You punch it on a calculator, it will definitely give you +9. So that's how you need to be careful. But if it was 3 there, it would mean 3 of the same thing. And if you punch it on a calculator, it would give you negative number. So just be careful of that. Then ended up realizing that if you have your exponent as even number, you end up having a positive. But if you have it as an odd number, you end up having a negative value. So then it means you have a challenge of trying to remember what is an even number, what is an odd number. How did I know? I knew it because I was told, but it was easy for me to forget. I had to find a way to easily remember. If you say 1, 2, 3, nay, let's say 1, 2, 3, 4. How many letters do you have there? You have 3 letters. Odd number has how many letters? 3. So O, D, D. What about even number? It has 4 letters. So that means E, V. So these numbers with the multiple of, what is it? Not necessarily the multiple of 3. But how did I claim it? I think I said now this one. So that means from 1 you jump to 3. You jump another number, then you jump to 5. That number is 4. Then from 5 you jump 6, you go to 7. From 7 you jump 8, you go to 9. Those are the odd numbers. But this one, that increases by 2, or you just jump that 2, you go to 4. Then from 4 you jump a number, you go to 6. From 6 you jump a number. Those are the even numbers. I just don't know how to best explain it. But for me, starting from 1, if you keep on adding by 2, you will always jump to the what is it? You will always jump to the odd number. But if you start from 2 and you keep on increasing by 2, you'll always jump to an even number. But you won't need to worry that much about this. I was just telling you in terms of how I used to claim the odd and the even. Even now, I still remember it that way, to say 1, 2, 3, 1, 2, 3, 4, and then starting from 1, jumping to 3 odd, and then from 2 jumping to 4. Yeah, you can find a way to memorize it, but if you already know, it's fine. So now with this one, it's clear that we're going to have positive 9 over x to the exponent of 3 times 2. Definitely that is 6. Okay, then let's look at another example, being C. This time around, let's say you have 3x squared, you have y, that is being divided by, let's say, z to the 3, and then let's close and say that. Okay, not that much complicated. You just need to remember that each base has an exponent. A base, it's not necessarily a letter. Even a number can be a base. So that means our first base is 3, invisible 1, second base x to the 2, and then there we have that to the that. So that means this exponent of 3 multiplies each base, or the exponent of each base. So that means it will be 3 to the exponent of 1 times 3. Again, you have that letter x, 2 that you multiply by 3. And then you have y, where you have 1 that you need to multiply it by 3. This is being divided by z. Just don't forget to say 3. Again, you multiply it by 3. And it should be easy to finalize because you have 3 to the exponent of 3. What will that be? Let me quickly check. I want to guess and say it will be 27. Let's see, 3 to the exponent of 3. Oh, yes. Yes, it is equals to 27. Then you've got x to the exponent of that times that. It should be 6. Y to the exponent of that times that. It should be 3 over z to the exponent of that times that. It should be 9. So this should be the end of it. Not that much complicated. A straightforward calculation to perform. Maybe let's continue and look at some more to see if we can squeeze in some negative exponents. So maybe let me just write there and say negative exponent. Very much important that you master this, because once you do, you will never struggle to understand any calculations in any form, because it's all about applying what you've learned regarding linear and the exponents. It starts there with you being able to understand how they've worked out a problem. Any other topic, trust me when I say it is easier to understand, because any type of a calculation is based on these simple laws. So now if we apply the law, let's say we have x to the exponent of m over x to the exponent of n. What we know is that it can be worked out as x to the exponent of m minus n. That we know. But in a situation where you are given, let's say, x to the exponent of 3 over x to the exponent of 5, if we work it out the same way we have done that one, we end up having this is 3 there, and it ends up giving us x to the exponent of negative 2. But also we do know very well that actually x to the exponent of 3 is the same as x multiplied by x multiplied, meaning 3 of the same thing. And then at the bottom we'll have 5 of the same thing. 1, 2, 3, 4, 5. Yes. So this cancels with that cancels with that cancels with that. Then you end up having 1 at the top over x and another x. And this ends up being the same as 1 over x squared. So I hope you are able to notice what I have done there. So in other words, based on that information, we can actually say if you are having x to the exponent of a negative number, this thing is actually the same as 1 over x to the exponent of positive that same number. Maybe to be fair, I will explain where the 1 is coming from, because someone might be wondering, where does that 1 come from? Remember, we said the structure of a term starts with the sign, the number, the letter, and then the exponent. So that means here we have invisible 1, and even there we have invisible 1. So it's not necessary for us to write that 1, but we know it is there. So that is where that 1 is coming from, which means if it was, let's say 4 there, then it means it was going to be 4 there. I hope that part makes sense. Okay, so that would mean if we have, let's say, x to the exponent of negative 1, I'm applying that. It means this is the same as what? 1 over x to the exponent of invisible 1, which is not necessary to write. I hope that part makes sense. So now let's look at a few more rules concerning negative exponents. Let me just create some space there. Just want to make sure that in one lesson I clear this part of the negative exponents. So maybe as number 1, let's say we have a, which is multiplying another letter to the exponent of negative n. Based on what I'm saying, it means this being your coefficient can just remain, actually let me say letter x there, just so that it is clear to see the difference. So that letter which has a positive exponent, it stays at the top. This one that has a negative exponent, it goes to the bottom. So in other words, we just want to convert any negative exponent to a positive exponent. So the one that has a negative exponent has to change the position. You will see as we continue. So let's say we have again a and then x to the exponent of n. Maybe let's divide this by b. Which base has a negative exponent? It is that one of x. So that means it is the one that will have to change the position. Changing the position, it means if it is in the position of the numerator, it will become the denominator. If it is in the position of the denominator, it will become the numerator. That's how it works. So that means you have a here that will stay because it has a positive exponent. This one stays there because it has a positive exponent. This is the one that has to come to this side, and that should be the end of it. Maybe let's look at another one. Let's say we have a over, let's say x to the exponent of negative n. So which exponent or the base has the negative exponent? It is that one in the position of the denominator. So now it has to change position. So this one, it stays as it is. It is this one that is joining, but with a positive exponent. So it's like we don't want to see a negative exponent. The moment you see a negative exponent, then you have to rewrite it by changing its position. Okay, what if now we have a over, let's say we have b that is multiplying x, and then let's say to the exponent of negative n. Same thing, the a remains because it has a positive exponent, but it is this one that has to change the position. Most importantly, the b remains because it has a positive exponent. So you see now we have the positive exponents. So now maybe let us look at this last one, a very interesting one that I would like for you to pay maximum attention on. Let's say we have x that is being divided by, and let's say y, and then this is to the exponent of negative n. What an interesting one. This one, let me not take a shortcut and say, remember we said this will have to multiply the exponent of each base. So that means you have x to the exponent of negative n over y to the exponent of negative n. So remember, you have that invisible one there and there. It doesn't matter even if you don't write it. I just wanted to make you aware. This one, be careful. You have this that has to change the position. You also have this that has to change the position. So that means y will go to the top as positive n, then x will go to the bottom having positive n. So don't be shocked in your textbook when they just skip all these steps that I've shown you, but all that they do is just to say it is the same as y over x, all of that to the exponent of n. I just don't have space, that's why I'm writing there. It's simply because the exponent of each base is still the same. You just swap. So it's like if you have, let's say, 1 over 2 to the exponent of negative 2. This thing is the same thing, but that goes to the top, that to the bottom, and then you just change the exponent to be positive. Just look at it carefully. You will realize that for me to end up having positive there, I had to swap these things. That's what I did there, even though I took a long try so that I could show you what happens, let's say, behind the scene. Maybe let me do just a few examples. Then from there, I think I will test you on different problems. Let's see. Okay, this should be fine. Okay, so now let's see. As the first problem, let's say you have 3x to the exponent of negative 2. Then this is multiplying y. Let's say this is multiplying, they say negative 6 there. It's not a minus, but it's negative 6 to the exponent of that. That is x to the exponent of that. Then you have y to the exponent of negative 5. Very much important that you master this type of problems, because if you don't, you are definitely going to have a problem when other problems in other topics are being worked out. But trust me when I say, if you pay maximum attention, you will fully understand. How do I usually approach this type of problems? Don't panic, don't worry much, just work them out nicely. How do you work them out? Group them. Yes, just group them. Let's see. This is a coefficient, this is a coefficient. Let's group them together and say we have 3 multiplying. Be careful, it is negative 6. That's why it's better to just put it inside the brackets. Then now let's group the letters. This goes with that one. So that means we have that x to the exponent of negative 2 multiplying that x to the exponent of 3. So you are grouping them in terms of the numbers, and the letters of the same type. So now we have that y, and you work it out with that y. Here you have 1, and then you will need to multiply it with this y having an exponent of negative 5. So can you see? That is it. What is that times that? You can nicely model it on a calculator. Say 3 multiplied by negative 6, it gives you negative 18. You can write this negative 18. Then here you have that and that. It's like you have negative 2 that you need to plus it by 3. It gives you positive 1. That's why you write x to the exponent of invisible positive 1. Then when it comes to this one, it's like you have 1 minus 5. So 1 minus 5, definitely that is negative 4. Okay, so now we just need to apply that law of saying we don't want a negative exponent. The negative 18, it remains as negative 18 because that is not an exponent. And then the x has a positive exponent. It is this one of y that has to change the position, and that should be the end of it. Remember, it doesn't matter even if you wrote it as negative and then you have that over there. It is still the same thing. That negative can be anywhere. As long as it is there, it is still the same thing. Okay, so now let's maybe jump on to another problem and see how far we can go. So problem B, and maybe let's do one that has the fractions and say negative 4. Let's say x to the exponent of negative 3. Then this is multiplying y to the exponent of negative 3. And so you just need to know that normally between the letters they put a dot. That dot meaning they multiply each other. So even if they don't put it, just know that they are attached by a multiplication, which is that invisible dot. As long as you have different letters, they are always multiplying each other. Unless if there's a sign of a plus or a minus in between. So just be careful you are able to differentiate between a minus and a negative. So it's fine. Let's now try to work it out. This one, how do we work it out? I think that there is something that we can start with. You see this negative, it cancels with that one. And definitely, if you say 4 over 6, will it not give you 2 over 3? I think it will give you 2 over 3. That's what I'm thinking. Most importantly, this is how I used to work it out so that I don't have problems. Let me just show you on the side and say it's a very safe method. If you have y to the exponent of 4 divided by y to the exponent of 2, I always said the smaller exponent visits the bigger exponent, which means this one has to visit that exponent, meaning it's going to be y to the exponent of 4 minus 2, which will be y to the exponent of 2. So what if it's y to the exponent of 2 over y to the exponent of 4? It doesn't matter. The bigger exponent will host the smaller exponent, or just remain consistent in saying the smaller one will visit the elder. So that means at the top you will have that one remaining, that invisible one. Even if you have 1, it's fine, but you will still say 1 y to the 4 minus that, and it ends up being 1 over y to the exponent of 2. So whichever way you work it out, you will still get to the correct answer as long as you can do things correctly. Let's say this same one, we don't do it this way that I'm saying let's do it. So that means we will say y to the exponent of 2, we take that 4, it visits that one. What do you get? You end up having y to the exponent of negative 2, because 2 minus 4 is negative 2. So you see now, we don't want a negative exponent. You will therefore remain with that one staying at the top, and then you will rewrite it like that. So same thing, but the only difference is how long it takes you to get to the final answer. So now it's fine. So let's come back to this one. It will only work if you know which number is bigger, because we say the bigger number visits, no, the smaller number visits the bigger one. So the question now is, if we deal with this basis of x between negative 3 and negative 5, which one is bigger between the two? From what I know is that we come from negative 5, negative 4, negative 3, negative 2, negative 1, and then we get to 0, then 1, 2. Remember the number line. So you will realize that these numbers, they always increase in that direction. So that means negative 5, it is smaller than negative 3. Just like negative 3 is smaller than that. Just like negative 1, it's smaller than 0. And then 0 is smaller than that. This is smaller than that. 2 is smaller than that. And so on. So that means it is actually that negative 5 that has to visit that. And remember, it changes the sign. If at the bottom is negative, the moment it goes to the new position, it changes the sign. So the question now is between this and that, which one is bigger? 2 is bigger, this one is smaller. So that is why you will have y to the exponent of 2, and then this one, it is the one that visits. Remember, it has to change the sign, and then it becomes positive 3. So now you still have your 2x to the exponent of that, and that definitely will give you 2. If you say negative 3 plus 5, and then you have 3, then that and that, it will definitely give you a y to the exponent of 5. And this should be the end of it. So maybe let me do this one, which is supposed to be complicated. Not that it is, but remember, you might need to redo these same things that I've done, just so that at least you will be able to understand them even better. So let's do this example C, and just use a black color there and say example C. Okay, let's open a bracket, and then we say 3x to the what? To the negative 2, and we divide these, let's say, by 2, y to the exponent of negative 3. So we are doing this as our last example. Then from there we will see how far you can go. Okay, then it's fine. Firstly, you look at the inside of the brackets. If you don't have the same bases, you don't have things that you can work them out inside, then in that case, it means you will therefore focus on that outside exponent. So what did the law say? If you remember, the law said for you to change this exponent from negative to being a positive, you need to swap those inside the brackets. So in other words, you will rewrite this, but these two y to the exponent of positive 3. Can you see what I've done there? It went to the top. And then that one at the top, it therefore has to go to the bottom. Just hold on. I'm trying to check something. I'm trying to check something, because if that one goes to that, it will also have to change the sign. Okay. I will need to apply this law correctly. Just be careful of something as I explain this part. It is actually those negative exponents that goes to the top as positive, and that one goes to the bottom as a positive. What a tricky one. What a tricky problem, because there are definitely multiple ways in which it can be worked out. I think the internal conflict that I'm having is whether I need to work it out in the shortcut approach or the long method. Definitely the long method will make you fully understand, but the shortcut, it will need someone who is experienced in order to understand, because I'll be hiding other important steps. Okay, let's just do it the long way, or let's do the long dry. If you remember, I said this outside exponent will have to multiply each base. I hope you remember this part. Multiply that, and again it should multiply that. So let's just do with that approach. You will see that everything will make sense as we continue. So if we have invisible 1, then we have invisible 1. Do you already agree that we will have 3 to the exponent of that? And then here we will have x. What is that times that? It will definitely be positive 6. Divided by, if you say this, you multiply it by that, we do not have 2 to the exponent of negative 3, where you multiply y to the exponent of positive 9, because it's negative times negative, it becomes positive. And you see what I've done there. So since I have actually multiplied, then it means I might not need those brackets, because I've already multiplied. So now you see what happens. We say these ones of the exponents, they will need to swap. So that means this 2 goes to the top, but with a positive 3. This x to the 6, it remains. But that 3, it is the one that has to change the sign, and then you have this y to the 9 remaining as it is. 2 to the 3, I think that is 8, and then x to the 6 over this one. I just remembered that we did it not long ago, and it is 27, and then you have that. So can you see the question is this something that goes into 8 and that 27? No. So that means this should be the end of it. And this is the long dry that I was talking about, even though it's not necessarily a long dry, but with the shortcut you definitely were not going to understand how we got to this final answer. But I'm just hoping that this way of doing it, it makes some sense. So how I'm going to test you, let me quickly check. It has been a lengthy lesson, but I just want to make sure that I test you not just with everything at once, but I will split it accordingly such that you've got level A type of questions, and then you also have level B type of questions. Let me just quickly verify here in terms of how I will work it out. Okay, then it's fine. I've figured out a way. So you might find that after you watch this lesson, you will just do, let's see, maybe 10 questions. Yes, just 10 questions, so that I will see how you perform. Then, in case if you fail from those 10 questions, then I will be able to know that there is something that we need to look at and work on it before you do level B type of questions, which will be many, where you're going to do some more work. So let me just conclude by just refreshing your mind regarding the laws where we summarize or we conclude. So in summary, we said if we have a to the exponent of negative n, this should be the same as a to the exponent of positive n. And I'm sure you still remember that a to the exponent of 0 is 1, meaning anything to the exponent of 0 is 1. Nay, very much important, that one. What else do I need to remind you? Okay, the other thing that I need to remind you is that when you have a negative base, but to the exponent of even number, you remember by now what an even number is, isn't it? You will always remain with a positive base. And then again, even if you have a negative base being a letter, as long as you have even number there, you will just remain with a positive base with that whatever even number. What else? If you have a negative number here, if you have that odd number, you remember most, we discussed this. Then if you have a negative, that having a variable or a letter, as long as you have that odd number there, you will definitely have a negative, still have that base, and then whatever the odd number there. I'm just summarizing what we discussed. Maybe let me just remind you of those laws to say law 1, if you remember, it is that one which says let's say m and then to the exponent of n, it is the same as this where you plus their exponents. And then let's say law 2, it is this one where you say if we have that being divided by, this is supposed to be m, and then if we have n there, therefore we can simply say this is the same as a to the exponent of m minus n. Then maybe let's talk about law number 3. Well, law number 3, it is that one where you are having bracket where it is easy, because all that you need to do is just to multiply their exponents. Then you should be done by doing that. Law 4, yes, law 4 is the one that confuses many. It needs more practice. So with this one, this multiplies that and it also multiplies that. That's it. That's it. It doesn't matter whether you have a number or a letter. As long as you have different bases, then you will multiply. So let's consider this to be law number 5. I think this is what we did a lot in today's lesson, where we are having that. Still same thing. This exponent multiplies that base, even that base at the bottom. Yes. So this is it, honorable member. This is it. This is it. This is it. Very much important that you take note of this information. I think I've covered everything that I wanted to cover. Very much important that you take note of all of this. At this stage, you can take a screenshot if you want to. Otherwise, you will watch it again and start writing down your notes. So do not rush to do the short test before you fully understand all that I've done in this lesson. The only way for you to understand it is to redo it over and over and over again. And before you can do some other problems, redo exactly what I've done. Try to redo this same thing that I have done. I think I'll leave it here for now and say until we meet